In this video, we'll set up Ceedling and Unity for C unit testing on Windows. This lesson is taken from my full course on unit testing reusable embedded C modules. For this course, we'll be using Ceedling, which depends on Ruby. So the first thing we need to do is install Ruby in our system. Go ahead and head over to the Ruby installer website, and I've included the link in the lesson resources. Once you're here, click on Download. This will take you to the Downloads page. Now, if you're not sure which version to choose, just follow the recommendation on the right-hand side. At the time of this recording, we're using the recommended Ruby plus DevKit installer, as shown here. Go ahead and select that version. Once you click it, the download will start. Then go ahead and save the file, and just give that a moment to complete, and I'll speed up the video here. All right, once the download finishes, go ahead and open the installer. And you may see a Windows security pop up like this. This is normal. Just click Run Anyway to continue. Just give it a moment. And now we'll go through the installation steps. Select your install mode. Then accept the license agreement. And here on this screen, you'll see a couple of important options. Make sure both of these are checked. Add Ruby executables to your path, and associate these files with Ruby. Adding Ruby to your path allows us to run Ruby and Ceedling directly from the command line. Once that's set, click Install. Next, we're asked to select components. Just leave the default options checked here, including the MSYS2 Development Toolchain. This is required for building native extensions, which Ceedling depends on. Then click Next. Now just give the installer a bit of time to complete, and I'll go ahead and speed up the video again here. Okay, once the installation completes, go ahead and click Finish. Now you'll see a command prompt open automatically for the Ruby installer. This is used to set up the MSYS2 Toolchain. Here it asks which components should be installed, and we'll press Enter, which will install the MSYS2 base system and the MinGW Development Toolchain. These are required for compiling native extensions, which Ceedling depends on. So go ahead and press Enter. Now this will run through the installation. And you'll see a lot of output here, which is all normal. Then they'll prompt you again, and just hit Enter one more time. Next, we need to quickly check our environment variables. This ensures the tools we just installed are accessible from the command line. So go ahead and open the Windows search and type environment variables. Then select Edit the System Environment Variables. Click on Environment Variables. And under your user variables, find the path entry. Now what we want to be sure is that the Ruby and MSYS2 paths were added correctly, or that we add them manually. You may already see entries similar to these, the MSYS2 UCRT64 bin directory and the Ruby bin directory. These allow commands like Ruby, GCC, and gem to work from the terminal. And if these are missing, you can paste them in. And I've included example paths in the lesson resources, but you can also verify yours by checking where Ruby was installed in your system. Once this looks good, click OK, and close out these windows. Okay, now let's verify everything from the command line. Go ahead and open a terminal. I'll use git command here, but a standard command prompt works as well. First, let's verify Ruby by typing ruby -- version. If everything was installed correctly, you should see the Ruby version printed here. And next, let's verify the compiler with GCC -- version. And this confirms that the MSYS2 toolchain is installed and accessible. And indirectly, it also confirms that your path is set up correctly. Now let's check RubyGems with gem -- version. And RubyGems, or just gem, is Ruby's package manager. This is what we'll use to install Ceedling. And now we're ready to install it. So go ahead and run the following command. This will take a moment. You'll see several dependencies being installed. Once it finishes, let's verify the installation by typing Ceedling version. And here we can see everything is set up correctly. You'll see Ceedling, Unity, which we use for testing, CMOC, and CException. These are the core components of the test framework. So at this point, the development environment is fully set up, Ruby is installed, the compiler is working, and Ceedling is ready to use. So let's go ahead and create our project. I'm going to place this directly in my C drive. So go ahead and create a new folder. I'll call this Embedded C Course. Now from this location, let's open up a command prompt. The easiest way to do that is to click in the address bar, type CMD, and press enter. All right, now from here we're going to create a new Ceedling project with the following command, Ceedling new, and call it Embedded C Patterns. This generates a new project folder for us, so let's take a quick look at what was created. Go ahead and open the Embedded C Patterns folder. Inside, you'll see source, test, and the project YAML. The source folder is where your production code will go. These are the modules we want to test. The test folder is where your unit tests will live. This is where we'll write our test cases using Unity. And then we have the project YAML. This is Ceedling's configuration file. And you can think of this as the project's build and test settings. Okay, now at this point, the project structure exists, but the test framework hasn't actually been generated yet. So from the command prompt, first, change into the project directory. Now we're going to run Ceedling test all. And this triggers Ceedling to set up the full test environment. It reads the project YAML configuration, generates build folders, pulls in the test frameworks, and prepares everything needed to compile and run tests by collecting source and test files, generating the test runners, and compiling everything with GCC. Right now, we don't have any tests, so you'll see something like no tests executed, and that's expected. But the important part is that the environment is now initialized. Now, if we go back to the project folder, you'll see a new build directory has been created, and inside build, we have a vendor folder, and this is where Ceedling stores third-party components. If we open that, you'll see Unity and CMOC. Unity is the test framework we'll be using throughout the course, and CMOC is used for mocking dependencies. Now let's take a quick look inside the Unity source folder. Unity.c contains the implementation of the test framework. It contains the actual logic that runs tests, handles assertions, and reports results. Unity.h is the public interface. This is what we include in our test files. It provides all the macros we'll use, things like test assert equal, and so on. Unity internals is internal to Unity. It defines lower-level structures, helpers, and internal macros. You typically won't interact with this file directly. Okay, so now let's take a look at the Unity test framework. Let's focus on the Unity header file, as this contains the test assertions we'll use throughout the course. At the top, you'll see it includes Unity internals.h. Then just below that, you'll see function prototypes for setup and teardown. These functions are intended to run before and after each test. So in your test files, you can use setup to initialize everything you need, and teardown to clean up after the test runs. In many cases, you may leave these empty, but they're very useful when your tests need a consistent starting state. Now, if you scroll down, you'll see a large set of assertion macros. These are how we validate behavior in our tests. They're grouped by type, so for example, Boolean assertions, integer comparisons, equality checks, and so on. Most of these follow the same pattern. You pass in an expected value and an actual value, and the framework checks whether they match. If they don't, the test fails. And if you scroll further, you'll notice Unity provides a very wide range of assertions. You'll find support for integer ranges, arrays, strings, structures, and even floating point comparisons. So Unity gives you pretty much everything you need to validate your C code at the unit level. And we'll go through these assertions step by step with actual unit tests later. For now, just get familiar with what's available. All right, now let's take a look at our working environment. I'll be using Visual Studio Code for this course. It gives us both an editor and a terminal in one place. Of course, you don't have to use VS Code. Any editor will work. But if you want to follow along exactly, I recommend installing it. So in VS Code, we'll go to File and Open Folder. Then navigate to your project directory and select Embedded C Patterns. Once you open it, you'll see your project structure here, the source and test folders, and your project YAML file. Now to open a terminal inside VS Code, just go to Terminal, then New Terminal. And this gives you a command line directly inside your project. From here, you can run Ceedling commands, build tests, and work with your files. So everything stays in one place, the editor and terminal together. All right, at this point, everything is set up. We have the toolchain installed, the project created, and the test framework ready to go. In the next section, we'll start with a quick warm-up. We'll implement some simple bit operations and use them to get familiar with writing and running unit tests. I'll see you there.